Hey everyone, this is Amritansh and welcome back to our videos about AGI, and today we are going to talk about Neuro Symbolic AI. As you know, my name is Amritansh and here I have Tamal Acharya with me. Hey Tamal, how are you?
Hey, Amritansh. Yeah, I'm good. How about you?
I'm good. Thank you so much. And sorry for our viewers, this video took a little longer than we expected, but here we are and let's continue. So as you guys know, we have been very deep and so far we have our 7 videos out, and I will really urge everyone to make sure you are updated with these videos. But in case if you already are updated, no need to waste time. And let's think and try to understand about neurosymbolic AI. Okay. Now guys, fundamental idea is we have heard about a lot about deep learning and all the newer models that we are talking about and pattern cognition, continual learning and all that. So neurosymbolic AI is this hybrid combination of neural networks that is kind of a self-learning process, like akin to how we intuitively learn. Okay. And also mixing up the symbolic AI, the good-fashioned or good old-fashioned AI, as we like to call it. And it's very reflective to how we rationally learn and how we build structures in our brain. Okay, and the idea is both of them have merged properly, would be able to work in a scenario which will be a kind of a mutual advantage, and it would like self learn from each other. Okay, and this is something that really excites me, and these are the ways and the research. It is kind of headed in these areas, our research methodology around AI as well. Okay, and as you already know, like we have been thinking and tinkering about, okay, how we can introduce more like causality, right? We had a small
Yeah.
discussion. And I think neurosymbolic can answer that, some of those questions. Okay. And one of the good ideas is this is fundamentally explainable AI, much more with knowledge graphs. Once you integrate with semantic technologies and symbolic systems into deep learning models, it gives you far more comprehensible artificial intelligence, which you could explain. Okay. And deep learning models also contribute to reaching unprecedented results in artificial, although albeit they are very narrow, but and also we are not many times able to explain them. How did we even reach to these results, right? And here, this is where this whole discussion comes, and knowledge graph, all of this can be merged. A knowledge graph could play a central role in such new design, particularly as novel architecture should embed causation and feature reasoning, and that is something that I feel is a paramount, or one of the paramount features that we need to develop into a modern, full-fledged AGI. Now let's just define this. Okay, this is also something we like to call as composite AI, and kind of it's a very new term. A lot of people might not be familiar with this one. Okay. And by basically combining AI's statistical foundation, so as you already know that classical machine learning algorithms, a lot of classical machine learning algorithms like regression itself actually come from statistics itself. Okay. And we can get the most effective cognitive analytic results with least number of problems and less spending. And that is what we want here. Now, you can or we can consider it as a very different version of AI than with AI we already know of, because it uses deep learning neural network architectures and combines them with the symbolic reasoning techniques. Okay. And this is the idea, like deep learning, we already understand, so I'm not going to go too deep here. But you know that how deep learning runs, you have multiple hidden layers, and we basically end up kind of putting all of them together. And all these computations that we are having has been, or like the deep learning, as you might understand, has been kind of a like a forefront runner into the modern state of the art algorithms, and let's call them algorithms and models. There is nothing better than that right now. No one can like deny this, but again, we know that there are definite problems here, like causation, explainability, right? And even many times, even if you have that, there's no future reasoning here. Like we cannot reason like how it is working out, right? Like any kind of counterfactuals is again like a discussion that we just can't have with the current day deep neural network. And this is where the idea of putting symbolic AI is so paramount and so very
Yep.
important. And as you, some of you already might know that symbolic AI was also used to be called good old-fashioned AI. Now, initially, this is how we started. This is how AI started, as in like if we would try to collect all the methods. Okay, which are based on representation of problems of logic and search, right? And the idea was we will be able to come up with these systems, and we will be able to put all these things together and that come up with rules that manipulate all these symbols, right? But then it is equally problematic because it just does not scale very well. Okay, how many rules are we going to have, right? So if you have a rule about how to identify a table, what if there is a different variation of table, right? How many rules are we going to have at the end of the day? And again, we had these ideas of logic programming, production rules, semantic nets, frames, as well as a lot of times whenever you hear something in industry being called as expert system, just immediately think they are just talking that a lot of symbolic AI or symbolic rules have been put into these systems. And that is what makes it a symbolic AI or a good old-fashioned AI. But that definitely didn't scale very well. So now what we are looking is just take this example as an example that you have these question answering scenarios. Okay. So the idea is, let's say you have been asked some questions. So the idea is, how do you get into AMR parsers, entity linking? Okay. And how do you link the relations at the end of the day? And all of this can be done in set of rules as well. But the problem is, if all the rules are devised by us and language as well keeps continuously evolving, it becomes really hard for us to imagine any language, or even let's say you are doing really good with one language, it does not translate very well when you deal with multiple languages. And this is what we are saying, that yes, we could do this, we can ask some questions and we could figure out a rule. So you can clearly see that we are getting some rule like, okay, so we are trying to understand what is this DBO that is filmed, what is the country, let's say it's a Spain, who is the producer, let's say Benicio del Toro, okay, and starring this person, right? So these things can be developed, but again, understand, if it has to be done, it would be really hard, because the question is, which actor starred in Spanish movies produced by Benicio del Toro? Okay, so we can come back and we can kind of split the overall text into relation linking, and we could try to get the logic done. Okay. But the idea is, unless we do not put the neural network, and you can see at the very end of the reasoning, you can see logical neural networks. We have mentioned it. Now, right now, it's very hard to come up with any neural network which we can really say it is going to be logical, but that is where we want to reach. That is exactly where we want to reach. And we want to develop these systems which could, let's say, in this example, can help us in question answering. Okay. So this is something that I find really fascinating, the way our research and the community is kind of moving forward here. And again, just to review and make sure that everyone of us is exactly on the same page. When we say what are the various components, we are talking fundamentally, let's say, the symbolic AI. That's rule-based. This approach was first official attempt using for creating artificial intelligence, and it reigned supreme in early days, 1950s to 1980s. And the idea was, the way we understand the world, can we just encode all that information, and can we create rules to define concepts and capture everyday knowledge, which is really hard to scale, even if whatever you know today will definitely change by tomorrow. So that was really hard to do, but that's how we started. And the other one that you already know that has become completely supreme these days, that you have these neural networks which work very different from your symbolic techniques, and it's very data driven instead of rule based. And it's good, because then fundamentally what we're saying is, as you are providing newer data, your model can also learn that. That's great. But then the problem is, but there's no causality, there's no reasoning, there's no structure that they are inherently learning. And this becomes a very big debate. Even in AI community, there have been quite a lot of debates, okay, around this idea that are neural networks good enough? And I am fairly sure this debate will never end, and everyone will make excuses that this works, this does not work. Let me be coming in front of this and say, I love what deep learning have done and achieved till this point. But we are smart enough to figure out what it has not been able to do. And if it is not working out, it does not mean we are saying let's discard it. No, I'm just simply saying, can we put symbolic? And again, we kind of do this. If you really think about any convention, when you think about a proper neural network, you might think artificial neural network, but we do know there are specialized neural networks like convolutional neural networks. Now, convolution, this knowledge has been put by humans because we understand we could extract features in a better way while using convolution operation rather than using simple matrix operation, right? The neural network did not automatically organize itself into a convolutional neural network. This knowledge was very much provided by us. So yes, there is some aspect of symbolic or rule-based part or some domain knowledge, expert knowledge that we have put over there. But let's think about, like, can we do it even better? Okay. And the idea is to merge these two things. The idea is to merge these three things. That the idea is, can we merge this idea of this free form learning and the symbolic logics that we had? And the idea is to come up with a much smarter and much powerful AI systems. And the idea is to deep learning helps symbolic AI in breaking the world into symbols, not by relying on programmers, but data itself. And symbolic AI should be able to incorporate common sense reasoning, domain know-how into the deep learning world. Okay, and together, if we come together, and we will kind of also mention some examples, we should be able to come up or work with so many different examples, like something similar, or like think about self-driving car. You might think it is very much super learning on itself, but no, there have been exceptional cases where the programmers have to code exact logic or exact reasoning over there. So all that is already happening actually. Okay, as we speak, it is already happening. And neural networks, so David Cox, director of MIT IBM Watson Lab, says this, that neural network helps in getting answers from messiness of the real world data to a symbolic representation of the world, constituting correlations in images. Together, they can do some pretty magical things in reasoning. And I do agree with this. I really, really agree with this, that this is where all of this is going to lead to. Okay. And of course, we have already talked about that it could solve when there are various startups. Okay, we can merge them with knowledge graph or rule sets. So we can use this technology in, let's say, self-morphing conceptual semantic network. It's like a hybrid here. And it could explain some black box explicitly. Like, we treat neural networks as almost like a black box that we understand okay, so we put something and we get a proper outcome, but we don't really understand what goes on in each hidden layer, right? And it is very hard to introduce trust over there. And again, based on connectionism, like the neural network and the knowledge graph, which is more of a symbolic based, we could even teach it to play a tic-tac-toe. Okay. And combination of neural networks and symbolic is an idea that has become more prominent. Gary Marcus, Louis Lamb, Joshua Tenenbaum, among other prominent scientists, are proposing developing neurosymbolic system that bring together the best of symbolic and learning-based system to solve the current challenges in AI. And let me just show you. Then this is the whole idea, right? There are different moves, and we not just use the neural network, but rather we also use the rule kind of a knowledge graph to solve a play and win the tic-tac-toe at the end of the day. So this is something that is kind of really exciting. Okay, and let's move forward. So as we have already talked about, and we have talked about that there could be different scenarios and there could be different outcomes. Okay, and so Dr. Henrik Toss, who is the founding director of the Institute for Data Science at University of Rochester, so he has categorized into 5 groups. Now, I will not go into details of each of them, okay? But the idea is we could have symbolic, neurosymbolic, okay? Where input and output are in symbolic, but all the inner processing is neural. And this is like your standard operating procedure. This is what most of the companies and most of the people who are developing are doing here. One could be that you could have a neural network pattern recognition subroutine within the symbolic problem solver. So everything is symbolic, but you just put a small neural package over somewhere in between. And this is something that AlphaGo, AlphaZero are doing, as a matter of fact. Now, there is also like a kind of a combination, okay, that symbolic rules are compiled during away training, okay, and it does not happen at that exact moment, okay. And you could have a neuro to symbolic, okay. There's a cascading from neural to symbolic reasoner, and one prominent example is neurosymbolic concept learning, okay. And neurosymbolic is, again, this is reverse now. Your symbolic reasoning is going to be embedded as a small module inside the neural engine, and this will kind of help in deliberative type 2 reasoning, which is really costly process at the end of the day. And many times this is where neural networks are not doing that well. So this is something that we are really interested in, and we are interested in building. I'm not sure which one will win because there are different ways of doing this thing, but let's see. But all of them are valid examples. The way people are introducing and implementing neurosymbolic artificial intelligence. Okay. Now we have this idea of logical neural network. Okay. And the overall idea with logical neural network has been that, again, it's a very interesting idea that you have the combination of neural and logical representation. Okay. And basically is based on Lucas's logic oversimplifying. It is like a real value fuzzy logic, which uncertainty range, which is helpful to spot contradictions. Like it can tell you when something does not matches up and how it can be different. Okay. And it can be created by using logic formulas. It performs inference using logic neural network and basically explains based on these LNN models itself. It's a very exciting developing area that is developed from purely statistical machine learning. But it also builds or it also relies on building connection of common sense and facts, and that can be applied to various problems such as like robotic path finding, AI planning, and NLP. Okay. And this is something that one could also look into while merging with quantum computing also. Although I'm not no expert in quantum computing, so let's not go there. Okay. So yeah. And the idea is, can we create? And I think that this is where I will also like to ask Tamal this idea that can we create some system that that's where AI could be as equal to humans as possible? What are your thoughts? Can it really lead to a strong artificial intelligence? So let's think about it, Tamal. Like, what do you think? Like, what could happen and where we could reach with this?
Yes. See, I agree with what is going on. The recent trends in development has been kind of, state of the art. I mean, that's why I'm saying this. Cognitive computing, along with AI, the kind of investments that is going on in these two fronts, like AI as getting system and cognitive computing, all the universities, Josh Stanimum and his team and others are there who are kind of understanding how the human brain works. Now, when it comes to merging the two fields, like cognitive computing and AI, at some point you need to think of symbolic reasoning.
Yeah.
Like our brain does, it understands everything. Okay, we don't really know. We don't really appreciate the fact that how fast it understands. If you give a symbol, some shapes and all, we'll know that what it is. If you give some symbols, we can easily connect what the symbol is. And if you give a series of symbols, probably we can write it out of it. Okay, we know how to connect those symbols. Now, for a system to do that, it needs training. Our brain is hardwired from the beginning. Since evolution has been that way. Like we are hardwired kind of to understand symbols, understand shapes and everything, and then try to make sense of it. The reason why the brain is like that, we have to go back to the prehistoric age. Like when we are hunter-gatherers, we are like hunting things. So we have to be mindful of the environment. We have to protect ourselves from all the elements. We have to explore, exploit everything. For that, our brain needed to have things which will defend us from, say, the predators and other elements from rain, snow, or everything. Now, that millions of years of evolution has taught us that we need to combine things, and now we take this for granted because our brain is kind of harder. That is the innate learning which is here. Now we understand things. Now in deep learning, symbolic AI, when you combine the two, like graph neural network is there, knowledge graphs are there, now the symbolic AI. Now, when you combine the three and then along with the state-of-the-art AI system like the deep neural network, you get a system which is capable of doing pretty much anything. Okay. Now, this is, where it will lead to AGI, the general intelligence. The moment you say general, it means that system should be able to kind of do pretty much anything that a human can do. That's why the general term comes. Yeah. Now, with causality, logic-based causality, now probabilistic approach, all these things needs to be combined as it is given here, a deep learning, say automated language processing, symbolic AI. We call it symbolic AI. Now, AI which is capable of understanding symbols, like when you combine all the things, you get a system which is kind of where do you want to go. Like there are systems now which uses kind of most of the things, like you say AlphaGo, AlphaZero. But I don't think there is a system existing that is capable of doing anything. There are like Gato is there, and there are others as well. Foundation models by Stanford is there. Now, all these things are state of the art, which is going there. I mean, when you train enough of these models, you kind of will go to the place where there is a symbol system which is capable of understanding things. Then the system can also understand things from text, and also understand things from symbol. That means you are reaching to a stage where it can be called general, like our human brain is. So although there is a debate whether human brain is specialized or general, because we train our brain like that. But I think our brain at some point can pretty much do anything. Like we can adapt to different places and situations, and then go from there. So that is where we want to go. Like purely probabilistic neural network. Like it need to a probabilistic element has to come. Now, when you combine the thing, we go to that. Like that's what AI aims. Like the heading says, the AI that aims to equal the human. Now, when you combine the thing, then only we can say that the AI has equaled the human. Right now, no. Right now, humans are ahead. So,
Yeah,
so
absolutely,
that's
absolutely.
yeah. We are going there. It will take few more years to do that, but I think that's. I mean, if you go to the next slide, see one thing which we as a do is learning from less data. We do it pretty much every day. Like we don't have like taking decisions, say understanding things. We have very less data. We can infer most of the things. So that's what the symbol system, the logical neural networks, which was discussed earlier. Now, these kind of neural networks, neurosymbolic AI, will outperform traditional deep learning in video and image recognition and analysis. Simply because videos and images are something, they are not text based. You
Right,
have to know how to connect the dots, literally. Like if there is a video, there is a series of video is nothing but series of images when played
right, right.
very fast. Now all those images have a story. That's why you say video. And so what the way to connect, it's not a text. You should not be forming sentences out of that. It's like you connect one image to the other logically, so that there is a makes sense. You cannot just haphazardly combine the pictures and try to make sense of it. It will become a random. It will not have a pattern. That's where the pattern
Yeah,
recognition comes into the picture. Now the system should be able to identify patterns. Hence, we introduced pattern recognition long back, like because this is one of the fundamental things which the system should have. Now,
absolutely.
combining all this, we will be going there, like AI that can equal human. Now, moving on. Now, there are solutions, like there are certain avenues of evolution which is there, like automated language processing, the large language models, as they say, like Lambda, GPT-3, BART, and all their variants. So the idea was to use a language model and pretty much tell anything, then it will give something out. Like nowadays, there are AI which, if you describe what you want, it will pretty much give you the picture. So just from text to image. Now there is a part and GPT variants, which actually, if you say write a poem, you give some hints, like some words you give, and the language model will come up with a poem or a story or something. Even all these language models was used to generate a film script.
Yeah, yeah.
So yeah. So this is where we are standing at an NLP stage, like these large language models. So all these things use some sort of reasoning techniques, because otherwise you won't be able to form logical sentences, or it will all be gibberish. So this LNNs, that's where the cognitive computing and symbolic AI should merge to create meaningful machine intelligence that can equal the humans. Now, if we move on. Now, yes. Now the last but not the least, like neuroscience, like understanding the human brain. That's where the AI field started. Like, how can we have a system that can equal the human brain? So I think neuroscience, if someone says that is neuroscience there, are enough contribution happening there? I think yes, it's not dead, at least because now there is a good paper on that. There's a good review paper, how deep learning is helping neuroscience and how
Yeah,
neuroscience is
I've
helping deep
read that
learning.
actually. Yes.
Yeah, it's very nice. Now, state of the art deep learning systems are helping the neuroscience researchers neuroscientists and brains to understand better the human brain, how the brain is wired, how it is working. The more we understand the brain, the more we'll be able to get to a point, get to a strong AI. Now, AI is basically what? Like the replica. You can say that we are trying to replicate the human brain. Now, you can only replicate if you know the thing better. Otherwise, you will replicate, but you will not go there somewhere.
Absolutely.
There's
And
a
I
good
understand.
you need to understand something in order to able to replicate it. Now, we have certain theories, we have an understanding over decades of research in neuroscience to how brain works, but still we are not 100% sure how it works, because there are certain things. Every day brain surprise you, like how it is coming up with things. That is where we are trying to understand now. That because Alexa, Siri, see, there are language models are there, like Alexa, Siri. Like we tell something, it actually shows you something. These are like, you can say, rule-based systems. Sometimes there are rules that's embedded inside this AIs, like Alexa, Siri. Then they also, given there is a certain rule-based things, they are also expected to generate things of their own also, which is called prediction.
Yeah, of course.
That's why sometimes it may not be able to find certain things. It is not 100% accurate. Like they are still training this every test, and every year they train this with different things, because if you tell something, it will say I cannot find, or it simply says it's unable to search, like that, because it's not able to understand what your requirement. Now that can be taken as an input to improve a next version of Siri. Now that is how the evolution happened. We also came like that. We made series of mistakes over the course of evolution. Then only we are reaching there. We're still going there. We'll not say that we reached that ultimate stage, but we are going there. But that's how the system should be. In order to build a strong AI is long way back, because we are not yet to understand fully the human brain, how it is work. Now, all the AI today are narrow AI, like focused on specific problems to cater. Now, if you want to make a general thing, now you need to train the model in such a way that it should be able to adapt to different environments. That's where the transfer learning comes into the picture. Now, you have to combine all these things. Then only you can. So that's where the cognitive computing, and that's what the title is, AI that aims to equal human. Now, the reason we included this particular thing here is because symbolic AI is something which is a fundamental, like symbolic AI will lead to kind of causality. We will understand cause and effect, counterfactuals, everything. Now, more you understand causality, more you will understand explainable AI. Now, explainable AI is something which is very hot these days. Now, symbolic AI, graph neural networks, and knowledge graphs are good at explaining things. Like that's why the explainable neural AI is getting some traction using these methodologies. So yeah, I agree with what you say. Like it needs to have, AI needs to have certain things in order for it to go to the next stage. So I think we're going there. All these researches and other things are helping there to make sure that it's not a science fiction, but it's science fact.
Yeah.
So yeah. So going on. Yes. Now, symbolic reasoning techniques.
Actually, I got it. So just let me ask you a question. So basically, just to let everyone know that we are basically trying to talk about symbolic reasoning techniques. Okay? So basically, I want to put Tamal on the spot here, and is the idea is like so whatever work we have done. Sorry, so whatever work we have done in neural networks, and we just want to understand that how are we really taking it forward? Like, so how does this symbolic reasoning really even matters, or like what it really does?
Yes. Now, symbolic reasoning, see, the way we work is like, our brain works so fast, we kind of don't know this, but the way brain works is like, if you tell me something, like some question, we have to think, like we're trying to reason it, like we're trying to put together the facts before I can answer you. Now, that's where that's what the second line says. Like the first, the human must learn the rules by which certain phenomena can relate. Then only they can hardcode the relationship into static programs. Now, the reason is you need to understand all the rules. So that's where the algorithm comes into the picture. Now, when we're in schools and colleges, we are first taught how to write an algorithm. Just write it in a plain English word, what you want to do. Then only you can code it. If you don't understand that, how to do, then your coding will be wrong.
Yeah.
That's why the symbolic AI also comes into the picture. The moment you ask a question, when you saw the question answer, there was a tree that was made. That's because Moment you ask a question, you try to put together all the facts. Then they have to relate the facts. That's where the graph neural networks comes into the picture. So all this, you will get a good graph.
Yeah.
Then only you can arrive at the point where you can say that, okay, this is the answer. Maybe right, maybe wrong, maybe close to the right answer, but at least we'll derive things and then you say something. But our brain does this very fast. You will not know. Moment to ask a question, if you know the answer, sometimes it's hardcore. If you ask me a question, I'll answer you straightforward. But if you ask me a question which I don't know, I may have to ask you, I'll need some time because I may need to put together the facts, then validate the facts, then I can tell that that answer.
Yeah, I agree.
Now, apply scientific reasoning is where we are, how we arrive at certain answers. Now, this is how a symbolic AI will look like if you say the symbolic AI to define an apple. Now, apple, it will have an origin, structure, kind. Apple is a fruit, it must grow on tree. Apple tree is there. The body of the apple, it's a fruit, the shape, size, color, all these things. Then you say that it's a red apple or a green apple based on the kind of fruit it is. I mean, if it's a green apple, then it's a green apple. If it is red, then it's a red apple. And and then how it is. Then if you ask a symbolic AI to define a bicycle, then same thing: origin, structure, kind, what kind bicycle shop is there. You has a frame, seat, there's two wheels, there's a seat, there's a handle, it's a vehicle, and it's built at a factory. So all these things will come. Then when you merge all these things together, then you say, okay, this is a cycle, this is a bicycle. And same thing with goes to identifying animals like dog, cat, and all. So this is how the symbolic AI will approach things compared to how the deep neural network will approach, which is in the next slide. Now, you give an apple shape, it will try to compare with the other shapes in the thing. Now, it will have some probability, as you see. So the last node, you see, all blacks, one is red. That means that, that particular node, that has the highest probability. So you'll get a series of probabilities with all the possible outcomes of that shape. The one with the highest probability will be the outcome answer, that's apple. Now, those black can be other things, but since the highest probability based on the training, based on pooling, convolution, and all everything, got that red. So that network was able to identify that is an apple. Now, this is how the deep neural network versus the symbolic AI will approach the things. Now, there are lots of use cases in neurosymbolic AI. Now, IBM has a very good workshop, or rather summer school on neurosymbolic AI. You should go there. The videos are made available free, but you should at least participate every year. They conduct this summer school on neurosymbolic AI. All the researchers will come there and they give their latest research and all, and also will get they'll give a challenge question, which if you can solve, you'll get a good you'll get a badge. But idea is, when you look at the challenge question, you will understand how. So there's a question, it will ask you to derive something based on the question. So there will be a series of statements. It will ask you to derive something. The answer will be there, but you have to derive something. You have to code that logic. That's why the logical neurators comes into the picture. You have to code the logic, the reasoning techniques. So there will be nodes, modules, which you have to call, and then you have to link it. But when you do that, you will understand how symbolic AI is working. So that's the broad idea of how the symbolic AI will work. Now, there are neurosymbolic systems, which different branches of computer science. Now, there'll be neurosymbolic AI has been one of the areas of research which all the leading researchers in all the universities, they are telling that it will help us solve many challenges of AI, which we are not currently able to solve. Now, going to the next slide. See, there is a gap. How do we go beyond the idea of intelligence as recognizing patterns in data and approximating functions, and more towards the idea of all the things the human mind does when you're modeling the world, explaining and understanding the things you are seeing, imaging. Now, imagining things. See, we imagine, we have this imagination. Now, machines can't imagine. You have to tell, the more you do symbolic reasoning, then the machine will be able to say that I'm moving closer to the human. We are not like processing data every day. Like we do approach certain things in a certain way. Like that's what Tenenbaum has focused, like the cognitive computing part, understand the brain, how it works. Now we are good at modeling the world. We understand things which is going on around it. Then we are able to solve the problems. So that's where the neurosymbolic
Absolutely.
AI should go. Yeah.
Yeah, definitely. And I think that as we are talking about different scenarios, and we are also talking about explainable AI, right? XAI, as people have like to call it.
Yes.
And, any XAI, like we are discussing that we should have descriptive power and deductive, inductive, explanatory, predictive, and prescriptive, right? So we are talking that it should be able to describe the problem, right? And then deduce something that might be hidden, and induce something in future, like whatever the pattern is currently going on, what will happen, or based on this information, what do we or where do we go with this, right? Explanatory, I think that is very explanatory itself. Predictive, like again, I think predictive is part of any machine learning, that yes, of course, any machine learning or deep learning does have a predictive power, but prescriptive is slightly tricky. Basically, prescriptive will mean that you have figured out what has truly happened, and it would require causality, it would require some kind of
Mm.
counterfactual checking. Without that, you will not be able to prescribe what's going to happen in future. And that is something that's very tricky. Predictive is fine. A lot of machine learning and means all of machine learning and deep neural networks can do the predictive part. But the prescriptive is not that easy. Even doctors, as you might
Correct.
know, who have been practicing for 20 years, can make mistakes. But the idea is, if you understand how human body works, how medicine works, we could do, and this is the whole point. Like at some point, we want to have, let's say, AI-powered doctor, right, or a medical professional.
Mm.
So just making prediction will not work over there. You have to prescribe something customer to customer or patient to patient, and that's gonna be really tricky. And that is something that we really, really want. Okay. And I think this is something that we are going in the correct direction. And this is what we are talking whenever we say explainable, that we want to go much beyond the simple neural networks, want to go in knowledge graphs and underlying semantic technologies where symbols can relate human learnings and deep learning, right?
Mm.
So yeah,
Yeah,
that's
that's right.
that's that's where we are interested to go, and we are kind of looking forward to be solving these problems as we are mentioning,
Yeah.
and kind of going on with this all this stuff. This is all interesting, and let's go on and try to go for the next one now. Okay, so moving on, and we want to think about this idea of neurosymbolic AI and rule-based coding, right? In coding. So, Tamal, I think you are.
Yeah.
I mentioned this, and it reminded me of this problem that it actually did happen. So, would you like to explain like what happened with Uber self-driving car when it hit pedestrian?
Yeah, it was an incident happened in 2018, and it kind of raised alarm bells everywhere. Like the self-driving car is kind of the hot topic of research, and when something of this nature happens, everyone starts to question: Is it safe? Is it good? Is it going to work? And all. So what happened is, so it hit a pedestrian, pushing her bike fatally and wounding her. Now, it was
Mm.
later discovered that the car's core system had been trained on countless hours of driving data, but the data did not include pedestrians jaywalking, nor did it include them pushing a bike across the street. Now, car did not simply able to classify the victim as a pedestrian, thus did not stop it at the
Yeah,
pit. Now, this incident highlighted one of the biggest and fundamental problems with deep learning. It is impossible to train a system based on deep learning on infinite scenarios. It's not possible. Now,
yeah,
even it has trained and handled 99.9% of the data, there will be 0.1% of the data, the cases where the algorithm will have no idea and it will fail. Now we have to address that 1.1%. I know it's not theoretically or practically possible to train everything on, I mean, on infinite set of data, or on infinite train for an infinite amount of time. So so yeah, so that results would be disastrous. Now it has happened like that. Now if we move on the next slide, what now that incident was proof that that pattern recognition alone could not be a source of an intelligent behavior.
yeah,
Now, this is all know that intelligence is something much more than just figuring patterns. So when women encounter unfamiliar situation, we use our experience to guide us. Now, simple bits of information such as fire is dangerous that makes a big difference. Now, this is where the innate learning comes into the picture. Now, innate learning is something which is there inside our operating system, the way we operate the
yeah,
system. So
absolutely.
yeah, now Gary Marcus has said many times that there should be a hybrid approach, neural nets to learn patterns, but guided by some old-fashioned hard-coded logic. That's where the symbolic AI will come into the picture. Now, on one hand, you have neural networks. In another hand, you have symbolic
Yeah,
symbolic
absolutely.
AI. Now, when you combine them, will get a hybrid system which will be able to kind of tackle many scenarios, which anyone was not able to tackle. Now, this is why it comes to a picture. So if I go by this picture, the picture says that it should identify a horse. Okay. Now, how do we identify the left hand side is where the symbolic AI will come to the picture, like hooves and tails.
Yeah,
hooves and tails. Then it's a white, black, and brown. And when we combine all these things using an and or, we get a logic. Then it's a horse. Now this knowledge needs to be transferred. Now, as you say, the neural network here is explaining where the weights are. Based on the weights, and the activation of the hidden neurons, the nodes here in the symbolic AI gets activated. Like you say, here's hooves and tail, and so here and gets activated here because of that net. So you say so it is able to explain each other. That's why the explainable AI is using the symbolic AI approach, like graph neural knowledge graphs, to better explain how the models work. Now, those things when combined gives a pretty powerful hybrid systems, which will be able to kind of handle anything. Now, if we move on. Now, Cleverer is one other picture. So Cleverer is one other system, which is collision events for video representation and reasoning. It's a large-scale video reasoning data set. Algorithm not only understand causal relationship, but was able to apply common sense to solve problems. Common sense is one of the things. Now, common sense is one of the things which was one of the properties of a general AI systems.
Yeah, absolutely.
Now, neurosymbolic hybrid system require less training data to make inference and draw conclusion. It also demonstrates the ability to outperform state-of-the-art deep learning models in images.
And I think we have an amazing picture here, and I think I could walk through this. That idea is that there could be simple descriptive questions. How many spheres are moving, right? So let's say the answer might be 2. But then there are questions like which of the following is responsible for collision with the gray object and the cube? And that is like the idea of presence of purple, the blue sphere. And you can see that for each of them, we will have to have our filter shape, filter move, and then the count. And based on that, we can come up with a response. And similarly, like what will happen next? This is the predictive part. And then the ultimate counterfactual, like, okay, if you remove the gray sphere, then what happens? Right. And all of this, if this works properly, or if there is a proper model which could solve this, and of course, there are a lot of things that we had to come up with. The idea was to put filter collision, filter ordering, and then query collision partner, like who is colliding with what, and then getting our final query shape. And this is not easy. Okay, this is not easy. And without, I do not see a simple neural network solving the outside, like simple deep neural network solving this one. You need to have some kind of innate knowledge here. Okay, so this is a very, very good example, and I would urge everyone to look into this data set.
Yes, that's right.
And so I guess we have been also thinking about graph neural networks. And again, we have mentioned a little bit about knowledge graphs already. And the idea is to combine the neural networks for the learning purposes, and all kinds of reasoning can come from your standard knowledge graphs. Okay, that you could build this, and let's say, and you build this and you come together over there. So let's say there's a new virus or some virus you are trying to scan. So neural network could represent the right features. But at the end of the day, does it have spikes? Does it have crown? Does it have capsid? All of them can be merged, and we could explain, oh, look, we are looking at a coronavirus, right? So this is something that will not be possible if you do not have a knowledge graph embedded. And again, creation of knowledge graph very much means we are putting our own innate knowledge in the play here. Okay. And this is like an approach that I would like to talk about. Okay. So guys, you have to understand there was always the symbolic approach. Okay. So like simple knowledge representation, reasoning, verification. Okay. And then we have our some statistical systems like machine learning, deep learning, neural networks, Bayesian inference, and graphical models. Where we are at, or what we want to reach here is we want to merge these things where we want to have neurosymbolic computation, okay, and logic as constraint and differential reasoning and neural probabilistic LPs, okay. And we want to basically maintain and merge all of them, okay. And we want to build this in a scenario which could be the perfect hybrid, okay. And this is like a perfect hybrid between symbolic AI versus sub-symbolic AI, okay. All right. So would you like to explain what's happening here, Tom? Like what is we are looking at?
Yeah. So, see, experts believe a neurosymbolic approach could be the next big thing. Does it live up to the claims? Now, always this question will be there. When AI first came into the picture, this question was there. Now, the picture here is saying neurosymbolic learning cycle, according to Bader and Hisler. Now, what it's saying is there's a symbol system. It is able to reason, it is able to refine knowledge. I mean, then there is expert knowledge, which is given input as a system. There is reasoning. Then there is something called connectionist system, which is training the thing, which is reasoning also. Then it exchanging the data. Like its representation is coming from the symbolic system, the extraction is good. And the symbolic system is able to extract the data from the connectionist system. Now, then when combining all these things, it is coming as a refined knowledge.
Absolutely.
Now, there is in 2009 manifesto, Neurosymbolic Cognitive Reasoning, Arthur Garris and Louis Lamb discussed the 1990s popular idea of integrating neural network with symbolic knowledge. So they cited something called a knowledge-based artificial neural network that uses a system to insert rules, define and extract data from neural network. A model empirically proving to be effective. That is what is represented here. That is that knowledge-based artificial neural network. Now it is able to insert rule and extract data from the neural network. Now those two are working in system, in tandem, symbolic and neural network.
Absolutely.
And then they're exchanging data among each other and then giving in the output the much more refined output as compared to if either one of them are working.
Absolutely. Yeah.
So moving on. Yeah.
So I guess all kind of let's have a discussion, and I think all kind of industry leaders from IBM, Intel, Google, Facebook, Microsoft, and a lot of top researchers like Josh Tannenbaum, Anima Anand Kumar, Yezin Choi are starting to apply this technique in, let's say, in recent year in 2022, the current year actually. And all of this has kind of led to, basically we want to challenge the stagnancy around deep learning, and we want to push into this hybrid model. And this is something that would be really interesting to see as we go deeper here. And it kind of combines, as we have already discussed, like this is inherent composition and combining of neural networks and symbolic AI. And this discussion can, of course, keep on going, but I am very interested in discussing this NLP, kind of neurosymbolic and NLP. So, so Tamal, like what we are really doing now, like, of course, we are seeing these massive, large language models, like we have started calling them LLM, large language models.
LLM.
Yeah. So what are we really doing and how we can improve our LLM sense?
Yes. Now, everyone must be aware of the apps, which is kind of says, I mean, it will ask for a symptom, it will give you certain response. Now, those kind of apps, if taken to the next level, like say, for example, here as an example, there's a GPT-3 language model being trained. Now, you ask the GPT-3 an open language model, which I mean, can you write a story? Now, tell me a story about Jack and Jill. We all know Jack and Jill. Now, tell me a story about Jack and Jill. Now, what it will do, given it is trained on a large language, it will try to come up with an answer. Now, what is happening here is basically there is a system, GPT-3, which uses ANN, say graph neural network, knowledge graphs, everything inside it. It will try to come up, and it is trained on a large amounts of data, say billion parameters and everything. So it's a large. So it will on text data. It is. It is trained. Now, when you use this hybrid neurosymbolic AI approach, you ask that particular app, which is trained on GPT-3 language model. You tell me a story, and what the language model will do, it will give you a story. Now, if you move to the next slide.
1 minute.
Yeah. Now, tell me a story about Jack and Jill. Responded with sample answers in course limited to string length. Now, this could be edited subsequently to make a story that had a semblance like human-like natural language response. And it will make mistake, like it is given Jack as a little girl, and I mean, it will happen. It will happen because it's not perfect and it is not trained. And so what happens is actually when an algorithm makes a mistake, what it will happen, it will retrain itself in the next iteration, and it will include those corrections once we say them.
Yeah, of
Now,
course.
this is what, so these kind of apps are there. If you go to these kind of apps where you give something, you tell something, and the app will respond with something. It may not be perfect, but at least it is something. So that means that
So,
a particular app with the underlying algorithm, the GPT-3 algorithm or anything, which NLP, large language one has been trained, it is trained in such a way that it is able to give you certain response. It is able to understand your question and then respond based on that. So this is
perfect.
what it is happening here. Yeah.
Yeah, that definitely makes sense to me. And yeah, progressively we are kind of encoding and giving our information and knowledge as well. And like again, I think this hybrid idea of neurosymbolic AI has always been basically that again, you basically build your symbol rationalization, you build exclusively, and you it is also like coming very close to the idea of consciousness. But I think consciousness is a discussion, a much bigger discussion that we need to
Yes.
have in some other video, maybe not today. But the idea is, what if this could also lead to, again, we are kind of hypothesizing here. This is not something that we understand very well ourselves as well. But this would be like a building of internal form of consciousness where this conscience could go on towards a moral compass and appreciation of purpose in a context, like in a context, what's really happening, right? So this is where we want to really go over there. And of course, we'll require some kind of hybrid neurosymbolic AI that we will be able to merge this. And I think, of course, we don't want to go too deep with the symbolic part. Okay, otherwise it might lead to AI winter. But the other worry is like maybe just completely dependent on deep learning will have the exact same problem. We might actually again run into a kind of a massive wall. And there are some limitations that kind of come out again and again and again, that we always see that something is incomplete with deep learning. And this is what we want to actually amalgamate with neurosymbolic in a neurosymbolic scenario and want to solve this one. Okay, and I think this is like a very good, cool example where we are trying to merge your neural networks. You are merging your knowledge graphs and all the information, and then you are merging them with LSTM GRUs for a time sequentiality. Okay, and like this is like a massive combination of neural networks and everything. And again, AI is our disruptive technology, but again, it lacks some finesse, right? And of course, IBM and a lot of other world industry leaders are actually looking into reinventing artificial intelligence. Okay, and this is something even I am greatly hopeful at, and this is something that I will urge people who are just like looking into a hard problem to solve in artificial intelligence. They should definitely look into neurosymbolic AI for this purpose, and this could be a thing that might become really big. This field might become really big down 4 or 5 years of time. Okay, and actually, me and Tamal are also very excited, and we might also be pursuing our own research in this field as well. So, and
Yes.
more on that a little later. Okay. And again, this is the whole idea that you basically merge all the information, and we have some information from WordNets, okay, Wikidata, and again, there could be domain-specific languages or knowledge that we could incorporate as well. And at the end of the day, guys, overall idea is to build these systems which could actually help humans, and of course AI ethics will come into play. Okay, because it is like you want to eat unhealthy, but maybe you should not eat unhealthy. So can we design a system which could help you in guiding around your food, like your fooding habits, or could it guide around your mental counseling, right? Although there could be a lot of complications, and of course we are not really suited to have these discussions, but I just explaining you this idea that it could still be very complicated, because the idea of morality comes, ethical concerns come, legal concerns, right? Maybe these systems are able to achieve AGI, but then the problem is, should you do what the human thinks what is best for them, or should you have a bigger understanding of the world and try to suggest humans what to do in order to prolong their life and existence on Earth? And this is a very tricky problem. Like, not everyone thinks on the same page here, right?
Correct.
And there are other projects like GPT-3 with OpenAI healthcare neural net-based NLP system. And it is like, it might start offering support to a test user to suicide, which is not something ideal, right? We don't want to do that. So you have to be very, very careful here that we should not be doing this. And there could be legal forms. There could be another application which will
Yes.
seek prosecution from human counselor. And if there is an accusation, they have been negligent. So there could be like this massive constraint and massive fight in future if we do not figure it out. And again, if it is just based on pattern recognition, of course, it's bound to go wrong. And we have been seeing a lot of examples. So yeah, I think this is a very interesting problem to be solved in future. Yeah,
Yeah.
definitely. I guess, Tamal, so I think we could actually try to conclude here, and we could think that fundamentally, let's just like really wrap it up and just simply think that there are issues with deep learning. Okay, we know that we require a lot of data. Figuring out right algorithm in terms of machine learning could still be tricky, and they have less ability to generalize. Okay, they are very much bound by the training data, and there is no creativity. And as I told, there could not be a prescriptive outcome. Predictive, that's all right, but prescriptive, I don't think so that's going to happen. So again, there are some some values like Shapley is there, but still they cannot explain how deep learning learns, and it's very much black box for us. And okay, we understand the overall mechanism, but we cannot explain what is going on each neuron and how they really contributed to the final outcome. Okay, and this is something that's great. And so what we really are doing, and I think Tamal, you can also pitch in here.
Yeah.
That with transferability, we can solve with symbolic AI. Okay, that we could tackle one problem, we may not be used to approach another problem due to fixed set of rules. And this is a big problem. Like if you had just symbolic system, it won't work. Okay, but if we could merge this with neural network, the idea is because again, symbolic AI would not work very well with the messy data such as images and sounds, right? And you cannot have exact specific examples for every ambiguous data. It is really, really hard to design all the systems upfront. So I think we could merge these two things, and we could have the ultimate learning from data using deep learning, and then we can bring the symbolic AI for the kind of the explainability, reasoning, causality that we want as a matter of fact. Okay, and
I agree.
Yeah, definitely that is where we need to go. And I guess we should be talking more, and we try to understand is that we want definitely these systems to progress. Okay. And again, there is a lot of resistance you have to understand. And me and Tamal always keep watching these videos where with a lot of deep learning people, there is a lot of resistance because they know it has failed already. So it is always a very tricky thing to suggest something that has failed in past. How do you bring that to the forefront of modern deep learning, and how do you really even combine? And many times computer does not know what symbols means, right? They are not really linked to any representation. This can become extremely tricky, but this is the problem. This is the problem that needs to be solved. And I am fairly sure that we can do this. It just requires the right amount of push in this direction. I would say that at now we are actually ending very close to kind of closing off our video series. And I think there will be two more videos. And I think, Tamal, we will be very soon talking about some novel architectures and what is the in long run road, where do we really want to go. But again, all of that for future videos. Okay.
Yes.
That's all, right, guys. And thank you so much for supporting us. And if you have any questions, queries, you can always ask us. And we will be looking into not so common neural network architectures in achieving AGI. And Tamal, thank you so much. And I think that's been already a very long video, so I would not waste anyone's time. But thank you so much for the support. And we'll try to come up with the next video really, really soon.
Really soon.
Guys,
Thank you,
so
everyone.
much.
See you. Bye.
Bye-bye.
See you. Bye. Bye.